All right, as a little warm up and review, I want you to think about how you would simplify each of these expressions containing fractions. So think about what would happen to the x's in the first problem, and in the second one, how would you multiply those fractions together after the exponent was applied? All right, so in this first one, and if you're not ready yet, go ahead and pause the video. But in this first one, keep in mind that anytime you're dividing or using a fraction and you have the same factor on the top and the bottom within a fraction, they are always going to cancel each other out because anything divided by itself is exactly 1. So in this case, I can take an x from the top and an x from the bottom and cancel them out. X divided by x is 1. I can do that another time because I still had an x on the top and an x on the bottom. And I can do this yet a third time because, again, I had another x on the top and the bottom. So I'm left with x times x times x times x in the numerator, which would then become x to the 4th power. So one of the properties we look at today with our division or quotient properties is going to take a look at what happens when you divide two powers with the same base. In other words, dividing x's by more x's. And I want you to think about what we did to get an exponent of 4 in this first example. Okay, that's going to come up in one of our properties. In the second example, number 2, we have a over b, so it's a fraction, or I guess you could call that the quotient, being raised to the exponent of 4. Now all that means is you're taking that fraction and multiplying it by itself 4 times, as shown there. So a review of how do we multiply fractions together? You multiply the numerators together, and you multiply the denominators together. So basically, it's going to be a to the 4th power on the top and b to the 4th power on the bottom. So I want you to think about, going back to the beginning, what did we do with that exponent and how did we apply it in our answer? And that's going to help us with our property today, which really is just explaining that shortcut of what always will happen. So let's look at our quotient properties of exponents lesson. The quotient of powers property is when you are dividing powers with the same base, we are going to subtract the exponents. And hopefully you saw that in the warm-up. So as long as I'm dividing two powers that have the exact same base of a in the algebraic example, all we have to do is subtract the two exponents. Because as you saw in the warm-up, it's like canceling out variables. If I'm canceling things out, I'm subtracting to figure out how many are left. As a numeric example, we're just going to take 6 to the 7th power divided by 6 to the 4th power. Well, as we saw in our warm-up, I could write this out. 6 times 6 times 6 times 6 times 6 times 6. That's 1, 2, 3, 4, 5, 6. And one more, divided by 6 to the 4th power. Now, every time I have a 6 on the top and on the bottom as factors, they can cancel out because anything divided by itself is 1. That's going to leave me with 6 times 6 times 6, which is 6 to the 3rd power. So I started with 7 of the 6's in the numerator, and I canceled 4 of them. And that's the math behind this. I started with 7. I took 4 of them away by canceling them out, and I'm left with 3 6's multiplied together, 6 to the 3rd power. So that's one of our properties today called the quotient of powers property. And it's important that it only applies when you have the same base. If I had something like x to the 4th power divided by y squared, I wouldn't be able to do anything with that because x's and y's are different. I wouldn't be able to cancel anything out if I wrote it in expanded form. Can only cancel out factors if they're the same factor, not different. So in this example, we have a bunch of 3's that are being multiplied together in the numerator and in the denominator. So if we wrote this in expanded form, just to give you a visual, let's see, 1, 2, 3, 4, 5, 6, 7. There's 8 3's multiplied on the top, and then just a 3 squared on the bottom. That's what it would look like in expanded form, but our property tells us that we can actually just take the exponents And do you remember what we do with them? We're canceling out common factors. So if I had 8 of them on the top and I canceled out 2 of the 3's with 2 of the 3's in the denominator, I am subtracting the exponents to tell me how many still remain. I had 3 multiplied by itself 6 times. My solution is 3 to the 6th power, which, since those are just numbers, we can actually multiply that out. We'd get 729 if we did that, of course, using a calculator. So go one more, this time without numbers. This time is our just variables. And if we have x to the 5th power in the numerator, that's just like x times x times x times x times x. And then we have the same thing in the denominator, x to the 5th power. We would see going the long way in expanded form, I can cancel out common factors. Cancel, 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 cancel. Basically, everything cancels out. If I use the property, I would see that I want to subtract the exponents, 5 minus 5, which will give me x to the power of 0. Now, do you remember what anything to the power of 0 is from day 1? It's 1. Anything to the power of 0 is 1. The reason why that works is because we have this invisible 1 here. Remember, when they cancel out, they're not canceling to equal 0. It's like 1 times 1 times 1 times 1 times 1 equals 1. When nothing remains, there's still that invisible 1 left behind. Let's look at our second property, called the power of a quotient property. This says that a quotient, in other words, like a fraction, okay, so it's 2 things being divided, that's a quotient. When it's raised to a power or an exponent, that's the same thing as taking that quotient of each base raised to the same power. This is kind of like that distributive property again. We're distributing the exponent to the numerator and to the denominator. Okay, so both the top and the bottom of that quotient, that fraction, get the same exponent. So in our example down below, we're taking 3/5 raised to the 4th power, which is really like multiplying 3/5 by itself 4 times, and then multiplying fractions, just go across the top and across the bottom. So 3 times 3 times 3 times 3, which can be written as 3 to the 4th power, and 5 times 5 times 5 times 5, which can be written as 5 to the 4th power. So we basically just distributed the exponent of 4 to the numerator and to the denominator. We probably could have also evaluated that since it's numbers. So 3 to the 4th power, I believe, is 81, and 5 to the 4th power is, I believe, 625. So technically, it would equal that. So here's another example, 3/4 to the 3rd power. If I wanted to just expand the exponent, I'm writing 3/4, which is my factor, multiplied 3 times because my exponent was 3. Well, if I'm multiplying fractions together, I know that that means I'm multiplying the numerators together, 3 times 3 times 3. I'm multiplying the denominators together, 4 times 4 times 4. Now my property would tell me just distribute the exponent, okay? Apply the exponent of 3 to the numerator and the denominator, and that's what we have visualized there. And then simplify each part. Well, 3 times 3 times 3 is 27. 4 times 4 times 4 is 64. So it becomes 27/64. Applying the property just basically is a shortcut. It's a faster way to get to 27/64. Now here's one where applying the property means we have to be very careful. We have a lot going on in this quotient, or this fraction that's being raised to the 3rd power. So we want to start by taking the numerator and raising it to the 3rd power, and the denominator and raising it to the 3rd power. Notice I took 2x cubed, raised it to the 3rd power, and then the yz raised it to the 3rd power. So we distributed the exponent there. Next, what we have to do is we actually have to apply a rule from yesterday. One of our rules yesterday said that if I have 2 factors being raised to the same power, same exponent, we want to distribute the power or the exponent to both parts. So I'm going to kind of split the 2 and the x cubed up and make sure that they each get raised to the 3rd power. So I have the 2 is raised to the 3rd power. My x cubed is raised to the 3rd power. And then even in the denominator, I do that same thing. YZ, remember, is y times z. So what I'm doing is I'm distributing the exponent to both factors within the parentheses. That what was grouped together. And it's going to end up becoming y to the third power times z to the third power. Now, I don't see any common bases here that I have to worry about trying to combine some things, but I do see that I still have some more properties that I can apply. I have, well, first of all, this 2 to the third power. That's 2 times 2 times 2, which is 8. So I can simplify that. But then I also have right here one of my properties from yesterday. We have our two exponents that are right next to each other. Do you remember what we do with those two exponents to simplify this part of it? Hopefully you said you multiply those two exponents. Since 3 times 3 is 9, that part of it's going to become x to the 9th power. So it's the 8 from the 2 cubed. X cubed cubed is x to the 9th power. And on the bottom, everything stays the same. It's just y to the third power, z to the third power. So if we think of our simplification rules, we make sure that each base only appears once. So I have an x, a y, and a z. All of the exponents are positive, which we have, and everything else has been simplified. That's our final answer for simplifying an expression like that. So it's important to just watch out, slow down, be careful with all of your properties, and really, when in doubt, write it out. If you're ever confused by any of this, it is okay to just write out what this would look like in expanded form. 2x cubed over yz times 2x cubed over yz times 2x cubed over yz. I write it 3 times because my exponent was 3 on the outside. And from there, you could just look at, well, what are you multiplying on the top? 2 times 2 times 2 is 8. X cubed times x cubed times x cubed. That's x to the 9th power, because it's like x times 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 x. So 2 times 2 times 2 is 8. X cubed, x cubed, x cubed is x to the 9th power. And on the bottom, we've got y times y times y is y cubed. And then finally, I'm going to run out of highlighter colors. Z times z times z is z cubed. There we go. Got everything color-coded, which is the exact same answer that we got there. So when in doubt, write it out. It does work, but sometimes it just takes a little bit more time. All right, so the properties are there as a shortcut, but you should get the same thing either way.